Good morning, dear students, and once again, welcome back to our course. In the last lecture, we discussed in detail about the theoretical aspect related to what exactly node analysis technique is, and we saw some numerical on what exactly node analysis technique and what is the meaning of supernode. And in the previous section, we also deal with the concept of mesh analysis technique. So the thing is that whenever we are dealing with node analysis technique, we need to apply some laws in order to solve a given network. For example, in case of node analysis technique, we need to apply the concept of law of conservation of charge, which is also called as Kirchhoff's current law, followed by Ohm's law. So these points we discussed in the last lecture, and we also saw some numerical that was asked based on this topic in the previous gate pattern. In the same way, when we are dealing with the supernode, now what exactly supernode is? It is nothing but a kind of structure where in between any two adjacent node, if we have a common voltage source, then it is very difficult to find out what will be the value of current flowing through this particular branch. And because we are not in a position to find out what exactly the current flowing through this particular branch, it is very difficult to apply straight away Kirchhoff's current law. And hence, while solving supernode, here we need to apply a combination of KCL followed by KVL along with Ohm's law. So whenever we have a questions based on supernode, or you can say super mesh, then in that case we need to apply a combination of Kirchhoff's laws that include both KVL, KCL followed by Ohm's law. And then we have some set of mathematical equations, and if you solve those mathematical equations, we can find out any operating parameter across any of the element connected in that particular circuit. So these we discussed in the last lecture. Now let us try to solve some more numerical on uh, say super mesh, which were asked in previous year gate paper. And once we have gone through these sections, then we will start our today's topic that deals with the network theorem. What exactly network theorem is? What are the different kinds of theorem which are available with us, through which we can have the flexibility to analyze given circuit that we are going to learn. And then most probably I'm focusing and targeting to complete the concept of source transformation in today's lecture. So let us begin with our course. So the first numerical that we need to solve in this lecture deals with the concept of super mesh. So when I say super mesh, that means in between two mesh we are going to have a common current source, and hence we need to apply a combination of KVL, KCL followed by Ohm's law. So the circuit is something like this. Here we have a active element, say plus, minus, and the magnitude of this active element is 10 volt, and somewhere out here we have a passive element of value 1 ohm, and here we have another active element of current source magnitude 2 ampere, and then here we have a resistor of value 2 ohm. Then here we have one more resistor of value 1 ohm. No, it's not 1, it is 3 ohm. Yeah, 3 ohm, and the structure is closed like this. And here our objective is to find the value of current supplied by this 10 volt voltage source. That means what is the value of current supplied by this 10 volt voltage source, that we need to find out using super mesh analysis technique. So first of all, in the numerical, it is not asked that we need to solve this by super mesh technique, but this is the kind of super mesh. Why? Because in this particular structure we have two mesh. This one will be a first mesh. Let us consider that this point is say A, this point is going to be B, this point is going to be C, and this entire point is going to be D, because this is going to be a single node. So if you see this structure, when we move from point A, then B, then D, and then coming back to A, so this is going to be our first mesh. And in the same way, when we move from point B, then C, then D, and then coming back to B, so this is going to be our second mesh. So in this particular circuit, we have two mesh, and in between these two mesh, we have a common current source. That's why it is the example for super mesh technique. So I told you that in the previous lecture, whenever we have a concept of super mesh, then in that case, we need to write first mathematical equation in terms of current by taking the resultant value of the current flowing through a common current source. That will be your first equation. And then second, we can club these two adjacent meshes simultaneously, and we are going to write uh, a single equation by applying Kirchhoff's voltage law. So the same technique we need to apply over here. Let us consider that the current flowing through mesh 1 is say I1, and it is going to be flow in clockwise direction. So here I need to take I1, and it is going to flow in clockwise. In the same way, let us consider that the current flowing through mesh 2 is say I2, and the direction is again in clockwise. So here I have assumed that both the currents like I1 and I2 in mesh 1 and 2 respectively are going to flow in clockwise direction. This is important. Now what we need to do? Now we need to read this circuit. And before that, first we are going to write one equations of current, that is I1 I2, with respect to a common current source which is connected in between mesh 1 and mesh 2. So by applying Kirchhoff's current law, or simply you can say that resultant of the current. So suppose we move in the direction from point D to point B. So if you focus on this structure, here we have a current source of magnitude 2 ampere, and on one side we have a current which is flowing in downward direction, and on the other side we have a current I2 which is flowing in upward direction. And suppose we need to find out the resultant, so I can write here as I2 minus I1, that is going to be equal to 2. So here I have taken that I2 which is moving in upward direction to be positive, so but obviously downward direction has to be negative, and because 2 ampere is in upward, again it is going to be positive. Or you can say that this I2 minus I1 is going to be 2 ampere which is in upward direction. So this will be your first equation. So this equation we got by applying simple Kirchhoff's current law in between the two mesh. Then we need to club by ignoring a common current source. We need to club these two mesh by ignoring this common current source. So I can apply directly Kirchhoff's voltage law between mesh 1 and mesh 2. So by applying Kirchhoff's voltage law in between mesh 1 and mesh 2, so first I'm going to move like this. By applying that logic, VR is positive and VD is negative. VR means voltage rise, I'm going to take at positive, and voltage drop I'm going to take negative. So when we are moving from point D to point A like this, we are experiencing a rise, negative to positive. So this is going to be plus 10. Then when we are moving through this particular resistor in the direction of current, because in initial case I assume that the current flowing through mesh 1 and mesh 2 are nothing but I1 I2, and both are in clockwise, and whenever we are moving in the direction of current, we are going to experience a voltage drop. So this is going to be equal to minus I1 into 1, because 1 indicate the ohmic value of that resistor. Then we need to jump and enter into second mesh. Again, in this case, we are moving in the direction of current. So here we need to experience a voltage drop, that is minus 2 into I2. And then again, we need to experience a drop which is nothing but 3 into I2. and then we have to close the path. So if you rearrange the structure and solve this equation, we can get here as I1, then this 2 plus 3, which is going to be 5. So 5I2 is going to be equal to 10. Let this will be your equation number 2. And then we need to solve equation 1 and 2. So here equation 1 is minus I1 plus I2 is going to be equal to 2, and equation 2 is plus I1 plus 5I2 is going to be equal to what? 10. If you solve this, these two get cancelled out, and here we can write 5 plus 1, which is going to be 6. I2 going to be equal to 10 plus 2, that is 12, and the value of I2 is going to be what? 2 ampere. So I2 we got as 2 ampere. In the same way, we can find the value of I1 by using equation number 1. So if you put I2 as 2, you can get the value of I1 as 0 ampere. Now what is I1? I1 is nothing but the current supplied by this 10-volt voltage source. That means the value of current flowing through mesh 1 is going to be 0 ampere. What does it mean? That means this particular voltage source is not going to supply any sort of current in mesh 1. This is very important, and this is what we need to find out. That means the value of current flowing or supplied by this 10-volt voltage source, and the answer is 0 ampere. This is very important. Now why this answer is 0? Can anybody tell me? See, the answer is very simple. I told you that in order to create a flow of current in any closed path, two conditions must be fulfilled. Number one, there must be a closed path, and number two, there must be a potential difference. If these two conditions are fulfilled in any circuit, we must have a finite value of current flowing through that particular path or that particular circuit. In this particular case, condition number one is fulfilled. That means we have a closed path, but potential difference is exactly going to be zero. Why it is going to be zero? Let us focus on that. Let me erase this. Now see here, we have the structure like this, plus, minus, and here the voltage is 10 volt, and then here we have a resistor of value 1 ohm, and this is something like this, and here we have a current source of value 2 ampere, and then we have a resistor over here and one more resistor over here, and the circuit is something like this. And if you see, here we have 2 ohm, followed by here we have 3 ohm. Now see here, we got the value of current flowing through this particular path as 2 ampere, because the value of I2 we just got as 2 ampere, that means clockwise direction. Now the moment the value of current is 2 ampere, which is flowing through this particular path, let us try to find out what will be the value of voltage which is going to be appear across these 2 points. Now suppose if you maintain this particular point as a reference node, that means this particular point is a 0. So with respect to this, the potential at this point is going to be 10 volt. Now let us try to find out what will the value of voltage available at this particular point. Again, this voltage is nothing but the voltage drop available across this plus the voltage which is going to be available across this. So I can write here as voltage across 2 ohm. It is going to be equal to what? I2 into effective resistance, which is nothing but 2. What is the value of I2? It is 2. 2 into 2. This is going to be what? 4 volt. And the direction is plus minus because current is flowing from higher to lower. In the same way, voltage which is going to be developed across 3 ohm resistor is going to be equal to what? Again I2, because these two are in series, multiplied by effective resistance, that is nothing but 3. So here 2 into 3, there is going to be what? 6 volt. And the polarity is plus to minus. Now let us consider that the voltage which is going to be developed across this current source is indicated by symbol say Vt, and by considering that this point is negative and this point is going to be positive, if you apply Kirchhoff's voltage law in this particular path, what you will get? See, if you move from 0 to this particular point, that means from minus to plus, we are going to experience a voltage rise. So I can write here as plus Vt. Let me change this. Yeah, we are going to get as plus Vt. Then we are moving through this, so we are going to experience a drop, and the drop is of minus V2, and there is minus 4 volt. So this is going to be what? Minus 4. And then when we are moving in clockwise like this, that means in this particular direction, again we are going to experience a drop because we are moving in the direction of current. And what will the drop? It is going to be minus 6, and this is going to be what? 0. So if you try to solve the value of Vt, you will get as exactly what? 10 volt. That means with respect to this particular point, the voltage available at this point is nothing but what? 10 volt. Now see here, just focus on this particular structure, this structure. Now in this case, here we have a resistor of value 1 ohm, and at one point we have a potential of 10 volt, and at the other end we have again the potential of what? 10 volt. So in this case, path is closed because circuit is closed, but if you calculate the value of potential difference across this particular element, it is going to be 10 minus 10, which is nothing but what? 0 volt. Because there is no potential difference available across this element, it is going to carry zero value of current. This is what the beauty of this numerical, and that's why this question was asked in gate. How much amount of current is supplied by this two 10 volt voltage source which is connected in this particular circuit? So in this case, though the path is closed, but because the potential difference available at two end of 1 ohm resistor is nothing but same, that is 10 volt 10 volt, that's why the value of potential difference is 0. And hence if you apply Ohm's law, we can write I equals to what? Potential difference which is available across that particular element divided by effective resistance. So this is going to be 0 by 1, that is going to be 0. Hence we got the answer as 0 ampere, and this is what the necessary condition. This you have to remember, that whenever you are dealing with a circuit, and suppose if you are interested to find out whether the current is flowing through that circuit or not, the thing is that the two conditions must be fulfilled. Number one, the circuit must be closed, and number two, there must be a potential difference. Then only it is possible to have a finite flow of current through that particular circuit. This is very very important. I hope this point is clear to everyone. Now let's try to solve one more numerical on mesh analysis technique, where we have a combination of dependent source. Now suppose if you have a kind of dependent source in case of super mesh technique, then how to solve that numeric? Again, this question was asked in previous gate paper, and the structure is something like this. So here we have a network. Then let us consider this point is going to be plus, this is going to be minus. Let the value is 10 volt. Same structure is there. I have just changed some fundamental aspects. This is going to be 1 ohm, and now instead of having independent current source, now I have connected a dependent current source. It is a dependent current source, and the value is 2 times of Vx. And then Here we have a resistor of value 2 ohm, and somewhere over here we have a resistor of value say 3 ohm, and the circuit is closed like this. Now this is a voltage controlled current source. Why it is called as current source? Because this is a diamond shape, and in that we have indicated a fixed arrow. That's why it is a current source, and the value of this current source is depends on voltage. That's why it is called as voltage controlled current source. Now what is Vx? Vx is nothing but the voltage which is going to be appear across this 1 ohm resistor, and the polarities are plus minus, and this is what Vx is. And here our objective is to find the value of this Vx. What is this Vx? How to solve this? Again, we need to apply the concept of mesh analysis technique. Now, before that, let us try to find out whether this is a plain mesh or a, a super mesh category numerical. Now, see here, we have two mesh. This is going to be your first mesh, and this is going to be your second mesh. And in between these two mesh we have a common current source. No doubt this current source is not a independent current source, it is a dependent current source, but again it is a kind of your super mesh. That means if we have a common current source, whether it is dependent or it is independent, it is possible to solve that numerical through super mesh technique. So let us consider that the value of current flowing through mesh 1 is say I1, and it is in clockwise direction. In the same way, the value of current flowing through mesh 2 is say I2, again it is in clockwise direction. Now what we need to write over here, first we are going to apply Kirchhoff's current law to find out the resultant equation of current based on a common current source which is connected between mesh 1 and mesh 2. So if you focus on this structure, here we have a voltage controlled current source, and the direction of current is in upward, and the magnitude is 2Vx. On one side we have a current I1 which is flowing in downward direction, and on another side we have a current I2 which is going to be flowing upward direction. So if you apply KCL over here, we can write the resultant current, that is nothing but I2 minus I1, is going to be equal to what? 2Vx. That this will be your equation number 1. Now why we have written here 2Vx? Because this 2Vx indicate the magnitude of this uh, voltage controlled current source. That's why it is nothing but 2Vx. Now let us try to find out what is the value of this Vx with respect to current I1. Now if you see this structure, this one, what is Vx? Vx is nothing but the voltage which is going to be appear across this 1 ohm resistor. Now if you apply Ohm's law, apply Ohm's law, I can write this Vx, which is nothing but a current or voltage which is going to be appear across this 1 ohm resistor. It is going to be equal to I into R. Now what is the value of current flowing through this 1 ohm resistor? It is nothing but I1. So this is going to be what? I1 into R, which is nothing but 1. So I can write here as Vx is going to be what? 1. Let this will be your equation number 2. Now if you combine equation 1 and 2, so from equation 1 and 2, I can write here as I2 minus I1, which is going to be equal to 2 Vx. Now from equation 2 we got that Vx is exactly equals to what? I1. And if you solve this, we can write here as this. If you shift on right hand side, so I can write this as 3 times of I1 minus of I2, that is going to be equal to 0. That this will be your equation number 3. So this is what we got the first equation in terms of I1 I2. That means 3 times of I1 minus of I2, this is going to be equal to 0. Now what we need to do, we need to apply the clubbing mechanism. That means now here we need to apply the concept of Kirchhoff's voltage law, and we need to club these two mesh simultaneously. So I'm reading this circuit in a clockwise direction like this. I'm going to write the expression for voltages. Whenever I'm going to experience a voltage drop, I have to take that as negative, and when we are experiencing a voltage rise, I'm going to take that as positive. So when we are moving through this 10 volt active element, we are going to experience a voltage rise and the value is plus 10 volt. And then when we are moving through this 1 ohm resistor, we are going to experience a drop and the value is minus I1. Minus I1 into 1, that is nothing but minus I1. In the same way, when we are moving through this element, that means 2 ohm and 3 ohm, we are again going to experience a voltage drop of 2I2, then minus 3I2, and now this is going to be equal to what? 0. If you solve this, I can write here as minus I1, then minus 2, and then 3. Here we have minus 5I2. This is going to be equals to what? Minus 10. Or simply if you multiply by negative on LHS and RHS, we will get this as an output equation. So let this will be your equation number 4. Now see here, equation number 3 we have in terms of I1, I2. Equation number 4 we have in terms of again I1, I2. Now the thing is that we need to solve these equations and try to find out the value of I1 and I2. And once we know the value of I1, we can easily find out the value of Vx, because according to our equation, Vx is exactly going to be equal to what? I1, and this is what we need to find out. That's it. So if you solve equation 3 and 4, here I can write this as I1, then plus 5I2, this is going to be equal to what? 10. If you multiply, say, equation number 3 by 5, so I can write here as 15I1 minus 5I2, this is going to be 0. The thing is that we need to add them, this will get cancelled out. Here we can write as 16I1 is going to be equals to what? 10. Or simply I can write here as I1 is going to be equals to what? 10 by 16, or we can write this as 5 by 8 ampere. Now from equation number 2, we know that I1 is exactly equals to what? Vx. So I can write here as Vx, which is going to be equals to what? I1, and this is going to be equals to what? 5 by 8. Now this is going to be volt, because we need to find the value of what? Voltage. So the final answer for this question is voltage, which is going to be developed across this 1 ohm resistor in this circuit, is 5 by 8 volt. So from this numerical, it is very clear that even though we have a dependent kind of active element, in this case it is nothing but a current source, that to a voltage controlled current source. Irrespective of that, we can easily apply the combination of super mesh technique, just we have applied to a plane structure where we have independent current source between a two common mesh. We can easily find out this particular circuit. So I hope this numerical is clear to everyone. And this type of questions are normally asked in GATE. The thing is that you need to practice more and more for such type of questions. Now, let us try to begin with a very interesting topic of today's lecture, that deals with the concept of network theorem. So, what exactly network theorems are, and what are the different types of network theorems which are available with us for network analysis purpose. Now, what is network analysis? Can anybody tell me what exactly analysis is? See here, analysis is nothing but a process in which, uh, suppose if we have a system, and to that system what kind of input we are applying in the form of excitation, this is known to us, and we are trying to find out what will be the output of this particular system. For example, we know that what exactly system is, and we also know that what kind of input we are going to apply to that particular system in the form of excitation, and we are trying to find out that if you apply this input in the form of excitation to this particular system, what will be the output. That process is called as analysis. For example, in this case, with respect to our course, this system is going to be either a network or it is going to be a circuit. That means we know the system. It means that we know what kind of structure is available with us, what kind of circuit is available with us. In the same way, we know input. That means we know excitation. That means what are the different types of sources or active elements connected in that particular system, that means in that particular network or a circuit, and we are trying to find out what will be the output. That means what will the value of current going through different elements, what will the value of voltage across different element, what will the power supplied or consumed by different element. So that is what the process of analysis is. This is very very important. So in general, what is analysis? You know the system, that means you know the network or you know the circuit, you know the what kind of input or excitations you have applied to that particular system, and the thing is that you are trying to find out what will the value of output. It may be in the form of current, it may be in the form of voltage, or it may be in the form of power across each and every element connected in that particular network or a circuit. So that process is called as analysis. And while doing analysis, we required some tool. So what are the different types of tool which are available with us that we need to learn under the category of what? Network theorem. This is very important. Already we have started this particular topic uh, before say 2 to 3 lectures in the particular series, because mesh analysis, then node analysis, the concept of super mesh followed by the concept of super node, then Kirchhoff's current law, Kirchhoff's voltage law, Ohm's law. These are also a kind of tool through which we can have the flexibility to analyze a given circuit. But apart from that, there are some specific theorems which plays an important role, and if you apply these theorems, we can easily find out the behavior of a circuit within a short span of time. So what are those type of theorems which are normally included in your syllabus as far as gate is concerned, that we are going to discuss. So the first technique that comes under the category of network theorem is source transformation technique. Source transformation technique. What is the meaning of this? That means if you have a source, when I say source, it may be a voltage source or it may be a current source. It may possible that it is going to be a dependent, or it may possible it is going to be a independent. So if you have a kind of voltage source, then how you can convert that into equivalent voltage source. In the same way, if you have a voltage source, how to convert that into equivalent current source, that we are going to learn under this particular topic, that is source transformation technique. And this plays a very important role in some cases. In order to analyze a circuit, it is very easy to convert, or it is very easy to apply source transformation technique first to solve the circuit in a very simpler manner. So that we are going to learn in this session. Then apart from that, we have the concept of superposition theorem. Superposition theorem. In short form, it is nothing but SPT, superposition theorem. Then third is Thevenin's theorem. Thevenin's theorem. Then fourth one is Norton's theorem. Norton's theorem. Then fifth one is my favorite, that is maximum power transfer theorem. Maximum power transfer theorem. Then apart from that, we have reciprocity theorem. Reciprocity theorem, followed by Telegin's theorem. Telegin's theorem. and then we have Millman's theorem. Millman's theorem, and then we have compensation theorem, or sometimes this is called a substitution theorem. Compensation theorem or substitution theorem. Substitution theorem. So there are some 8 to 9 theorems which plays an important role for the analysis of given network or a given circuit. But out of this 8 to 9 theorem, as far as gate portion is concerned, the most important theorems are first five. First one is source transformation techniques. Actually, source transformation technique is not a theorem. It is nothing but a kind of methodology through which we are in a position to convert a voltage source into equivalent current source or vice versa. So as far as gate is concerned, this is very important. And then serial number 2, serial number 3, 4 and 5. That means from superposition theorem, then we have net Thevenin's theorem followed by Norton's theorem. In Thevenin's theorem, we are trying to convert a given circuit into equivalent voltage source. In case of Norton's theorem, we are trying to convert given circuit into equivalent current source. Then maximum power transfer theorem. This is very important, and in most of the cases, you have a lot of questions in previous year gate based on this particular theorem. Then some weightage is also given to reciprocity theorem. In previous gate years, we have some numerical based on reciprocity theorem also. But apart from that, this Telegan's theorem, Millman's theorem, then compensation theorem, they have a very little weightage as far as gate is concerned. So because we are preparing for gate, our objective is we need to just focus on the topic which are most commonly or most frequently asked in this. And those topics are the concept of source transformation technique followed by superposition theorem, then combination of Thevenins followed by Norton's, then we need to deal with this, that means maximum power transfer theorem. And in some cases you may have some kind of question based on reciprocity theorems too. So these are first 6 topics which plays an important role whenever you are preparing for gate exams. I hope this point is clear to everyone. So now let us try to focus on what exactly this source transformation technique is and how this technique plays an important role in order to analyze a given network. So let us deal with this, that is source transformation technique or method. Source transformation method or source transformation technique. Now from the name itself, it is very clear that in this particular technique or in this particular method, we are going to transfer a kind of source from one nature to another nature without disturbing its equivalency. Now what is the meaning of this? For example, we know that from the topic which we have covered in our previous lectures, we know that we have the indication of practical voltage source, practical voltage source, like we have an ideal voltage source which is fixed polarity plus minus of value say 10 volt, and in series with that we need to indicate its internal resistance. Let us consider that the internal resistance of this voltage source is say R in. So this is nothing but a representation for practical voltage source. Now suppose if you want to represent this practical voltage source into its equivalent practical current source, then how we are going to represent that? First, what we need to do whenever you are trying to apply the concept of source transformation method, remember one thing: whenever you are trying to switch a source from voltage to current or from current to voltage, the value of resistance is not going to be changed. That means if uh, the previous source offers some kind of internal resistance, the same resistance is going to be offered by a transformed source. The reason is very simple. See, what is this? This is nothing but internal resistance, and it is due to the material which we have used for the fabrication of this particular uh, source. Now, because we are not trying to add any kind of additional material, the thing is that whatever the kind of material we have with us, through that we are going to transfer one particular source into another. That means the value of this internal resistance is not going to be changed. This is very important. Now, because here we have a practical voltage source and we want to convert that into a practical current source. So first what we need to do, we need to draw the diagram for this practical current source, how it is going to be look like. So I know that I told you that a practical current source is nothing but a combination of current source, and to that we need to connect a internal resistance, that too in parallel. This we already discussed in our previous sections. If you forgot, just go back, watch those videos. You can find out why we have connected a resistance, or you can say internal resistance of practical current source in parallel with ideal current source. So here, let us consider that the value of this current source is say I. Now I told you that because here we are applying the concept of source transformation technique or source transformation method, the value of internal resistance will remain same on both the cases. So here the internal resistance of this voltage source is R in, same R in is available over here. So this is going to be what? R in, it is not going to change. Then which value is going to change? This, that means the value of current is going to change. Now how to find the value of current? Now here we need to find the value of current by applying Ohm's law. That's it. So if you apply Ohm's law, we can write here as I equals to what? V by R. Now in this case, what is V? V is 10 volt. So I can write here as 10 divided by R. What is R? It is nothing but the internal resistance of this voltage source. So this is going to be equals to what? R in. So the magnitude of this I is nothing but 10 by R in, and the unit is ampere. So I'm going to write this as 10 divided by R in, and the unit is ampere. If in a circuit you have this structure like a 10 volt voltage source in series with internal resistance of R in, the same particular circuit you can replace by a current source in parallel with its equivalent resistance, where the magnitude of that current source is going to be 10 by R in, and the unit is ampere. I hope this is clear to everyone. This is what the philosophy behind source transformation method. In the same way, you may apply reverse technology too. That means if you have a, a current source like this, a practical current source, say the value of this practical current source is 2 ampere, and the internal resistance which has to be connected in parallel, say 100 ohm, and this is what the point is, say A and then say B, and suppose we want to convert this into its equivalent practical voltage source. How to convert that? First, what we need to do, we need to draw the structure for this. So here this terminal is say A, this terminal is say B. Now because this is a practical voltage source, and in practical voltage source we have ideal voltage source, and in series with that we need to connect its internal resistance. So here we need to have a resistor, and then we need to take this. Now because arrow is in upward direction, which is connected to terminal A, and down portion is connected to terminal B, that's why nearer to terminal A we need to indicate positive polarity, and near to terminal B, because arrow is not available over here, it is supposed to be a lower portion, that's why here we need to take this as negative. I hope this point is clear. Now what will be the value of this internal resistance? I told you that whenever you apply source transformation method or source transformation technique, the value of internal resistance is not going to be changed. So here previously this practical current source offer a ohmic loss of 100 ohm, so the same 100 ohm is going to appear over here, because we are not change the material which we already used to fabricate this current source. Same material is going to use to fabricate this voltage source, hence the inter resistance is going to be unchanged. Now what will the value of this V? So it is going to be simply the application of Ohm's law, that is going to be what, I into R. Now what is the value of I? I is 2, so here we need to take 2 multiplied by R, resistance, which is nothing but what, 100. So I can write this as 200 volt. So if in a circuit we have a combination like this, 2 ampere in parallel with 100 ohm, this is exactly going to be equivalent to a 200 voltage source in series with 100 ohm resistor. They are nothing but exactly the same. So this is what the concept of source transformation technique. This is very, very important. I hope this is clear to everyone. This is very important. Now, the same logic you can apply to dependent sources also. For example, if you have a kind of dependent source, it may be a voltage source or it may be a current source, and if you want to convert them vice versa, how to do that? Let us try to have some quick cases for that. Let us consider that we have a dependent source like this. Let us consider that this is say A and this is going to be say B, and the value is say 2 ohm, and here we have a voltage control current source. You can take any value. Suppose I take this as 2 of ix. So this is nothing but a current control current source. And suppose if you want to represent this into equivalent voltage source using source transformation method or source transformation technique, then how to apply that logic? Again, first we need to indicate the two terminals. This is going to be A and this is going to be B, and because now here in this case we are going to convert this dependent um, current source into a kind of dependent voltage source. So ultimately it is nothing but a voltage source, that's why it must have the internal resistance that is going to be connected in series with your dependent voltage source. So the structure is something like this. So here we have internal resistance that is going to be connected in series with this particular dependent voltage source. Now what will be the value of this internal resistance? It is going to be 2 ohm, because I told you that whenever we apply source transformation method or source transformation technique, the value of internal resistance is not going to be changed. So here we have 2 ohm, the same 2 ohm is going to be appear over here. Now look at this arrow, it is connected to terminal A, that's why the terminal A point has to be positive and terminal B point has to be negative. Now this is going to be a dependent voltage source. Now on what factor the value depend? That depends upon how the value of this dependent current source is going to be controlled. So this dependent current source is nothing but a kind of your current controlled current source. See, this is nothing but a current source, and the value of this current source is decided by 2ix, where ix is nothing but a kind of current going through some element available in the same circuit. So it is nothing but a current controlled current source. Now because this is a current controlled current source, that's why whatever the form of voltage source which we are getting as an output, again it is going to be controlled by the same value of current. So here we need to find the value of this V, which is going to be equal to application of Ohm's law. So it is simply the product of I into R. Now what is the magnitude of this I? The magnitude of I is nothing but 2ix into R. Now what is the value of internal resistance? It is nothing but 2. So 2 into 2, this is going to be equals to what? 4ix. So the magnitude of this voltage source or dependent voltage source is going to be equals to what? 4ix. So this is what the kind of current controlled voltage source. Now see here, in this case initially we have a current source that we converted that into a voltage source. But in the previous case, the magnitude of that current source is controlled by current. In the same way here also, the magnitude of this voltage source is again controlled by the same current. See, this is what the Ix, which is going to decide what will the magnitude of this current source. In the same way, this is the same Ix, which is going to decide what will be the magnitude of this voltage source. So this is what the beauty of source transformation method. And one thing is very clear, that source transformation method is applicable for both dependent as well as independent type of sources. If you have a voltage source, you can convert that into equivalent current source, or if you have a current source, you can convert that into equivalent voltage source. The thing is that just you have to remember this structure. That means if you have a practical current source, a combination of ideal in parallel with its equivalent resistance, or if you are dealing with practical voltage source, ideal voltage source in series with its equivalent internal resistance. This you have to remember. That's it. Now based on this, let us try to solve some numerical which were asked in previous year gate exam based on this topic. So this was the question which I'm supposed to take over here, was asked in gate 2009, and the structure is something like this. We have somewhere over here terminal X, and here we have a voltage source, then in series with that internal resistance, followed by another voltage source in series with that one more internal resistance, and like this. And then we have another resistor in series with that one more voltage source, and then another resistor in series with that one more voltage source. And the structure is supposed to be closed like this. So this point is going to be the Y terminal. And what are the values given to us? So the values are, here we have plus, minus, and the magnitude is 10 volt. Then we have plus, minus, magnitude is 6 volt. Then here we have 2 ohm resistor, and here we have 3 ohm resistor, and here we have again 2 ohm resistor. This is 1 ohm resistor. Then the magnitude of this voltage source is plus minus, and this is going to be 6 volt. And the magnitude for this is plus minus. No, it's not plus minus. Let me erase this. It is minus plus. It is minus plus. Minus plus, and the magnitude is 3 volt. And our objective is, we want to represent this particular circuit into equivalent voltage source. So our objective is, we want to reduce this entire particular network into equivalent voltage source. That means by the end, between terminal X and terminal Y, we must find out a equivalent resistance followed by a voltage source. What will be the value of this V? What will the value of this R in? That we need to find out using source transformation method or source transformation technique. This question was asked in GATE 2009. So how to solve this numerical? Again, as I told you that whenever we need to solve the circuits, the thing is that it is easy when we connect a current source, when they are connected in a parallel configuration, it is very easy to find out their resultant. In the same way, if we have more than one active source, and if all the active sources are connected in series configuration, it is very easy to find out their equivalent by using voltage technique. That means if you have more than one source in series combination, it is very easy to find their equivalent when all are them in voltage configuration, because in series we can easily find out their resultant. In the same way, if the sources are connected in parallel configuration, it is very easy to find out their equivalent if all are of kind current source. So this technique we need to first implement over here. Now see here, in this case we have uh, this as a practical voltage source, and this is again going to be a practical voltage source. Now both are connected in parallel configuration, and I told you that whenever the sources are connected in parallel configuration, it is very easy to find out their resultant when they are in current source category. But here we have voltage source, so what we need to do, first we will apply source transformation method to convert these voltage source into equivalent current source. In the same way, look at here, this is nothing but a kind of your practical voltage source. This is ideal voltage source in series with that its internal resistance. In the same way, this is going to be another practical voltage source, and both are connected in parallel configuration. So what we need to do, we need to apply the concept of source transformation technique to convert these voltage source into their equivalent current source, and then we need to find their resultant. So by applying source transformation technique, I can draw this circuit like this. So I'm directly applying that logic. So here we have terminal X. This is going to be terminal X. First, I'm going to convert this 10 volt voltage source in series with 2 ohm into equivalent current source. So how it is going to be like this? It is going to be a circle, and somewhere over here we need to have its internal resistance. Now what will be the value of this internal resistance? It is going to be the same, it is nothing but 2. And what will the value of this current? Again apply Ohm's law. So this I is going to be equal to what? V divided by R. Now what is V? It is 10. What is R? It is 2. So 10 by 2. This is going to be equal to what? 5 ampere. So the value of this current source is nothing but 5 ampere. Now what will be the direction? It is going to be either in upward or it is in downward. So see here, here this plus polarity is with respect to terminal X. So whenever we have plus, we need to indicate arrow over there. So arrow has to be in upward direction. I hope this is clear to everyone. So this is what we have converted this 10 volt 2 ohm voltage source into 5 ampere 2 ohm current source. In the same way, same logic we need to apply over here. Convert this 6 volt 3 ohm voltage source into its equivalent current source. So somewhere over here we need to have a current source, and here we need to indicate its equivalent resistance. So equivalent resistance is nothing but 3 ohm, it is not going to change. Now what will be the value of this current? Again apply Ohm's law. So here voltage is 6, resistance is 3, so 6 by 3 is going to be 2 ampere. So this is going to be 2 ampere. And what will be the direction? Again apply the same philosophy, plus nearer to terminal X, that's why arrow in upward direction. This is very important. I hope this is clear to everyone. Again apply the same logic to the remaining portion of the circuit. So here we have a current source followed by internal resistance. In the same way, somewhere over here we have another current source with its internal resistance. Now what is the value of this? It is going to be 2. And what is the value? It is going to be 1. Now what will be the value of this current? This current is going to be 6 by 2. It is nothing but 3 ampere. Very good. And it has to be in upward direction. Now it has to be in upward direction because see, plus is in upward. That's why arrow has to be in upward. Minus downward. That's why this terminal Y has to be over here. In the same way, now see here. This particular voltage source, positive terminal is toward Y. That means arrow has to be in downward direction. So this is going to be in downward. This is very important. So all are in upward, only this one is downward, because see, all are plus minus plus minus plus minus, but this is minus plus, that's why downward. And what will be the value of this current? Again it is going to be I equals to V by R. So V is 3, R is 1. So this is going to be 3 ampere. I hope this is clear to everyone. So 3 ampere. Now let us try to find out their equivalent current source over here. So how to find this its equivalent current source? Now see, in this particular parallel combination, here we have uh, one current source of 5 ampere which is in upward direction. In the same way we have 2 ampere current source which is again in upward direction. So if you want to find out its equivalent, it is nothing but 5 plus 2, it is nothing but 7 ampere which is in upward direction. So here I can replace them by 7 ampere which is in upward direction. In the same way, let us try to find out their equivalent resistance. Now see here, in order to find their equivalent resistance, just ignore this. Let us consider that we don't have any kind of active element over here. So we can ignore them, and the thing is that we have only 2 ohm resistor in parallel with 3. So we can write here as 2 ohm in parallel with 3. So how to find this? Apply direct formula, that is nothing but 2 into 3 divided by 2 plus 3. So it is going to be equals to 6 by 5. So here I can replace them like 6 by 5 ohm in parallel with a current source of magnitude 7 ampere, and the arrow is in upward direction. So this terminal is going to be your X. I hope this is clear to everyone. It is simply the application of Ohm's law followed by equivalent resistance technique. In the same way, let us try to find out what will be the equivalent of current in the lower half. See, here we have 3 ampere in upward direction, and here we have 3 ampere in downward direction. So they will cancel out each other. So here we don't have any current source connected over here. So we can ignore that. We don't have current source, or you can, or if you want, you can take a current source maybe in upward or downward direction, and the magnitude is going to be what? 0 ampere. So connect करना क्या नहीं करना क्या एक ही बात है. You may take this like this, or you can simply ignore that. In the same way, let us try to find out what will the value of equivalent resistance over here. This is y. So here we have 2 in parallel with 1. So we can write here as 2 into 1 divided by 2 plus 1. So it is going to be what? 2 by 3. So this is 2 by 3 ohm. I hope this is clear to everyone. Here we have simply apply Ohm's law followed by equivalency to find out the resultants of all the current source which are connected in the first and the second half portion of the circuit. Now what we need to do, see here, this particular portion indicate a kind of practical current source, and here again this particular portion indicate a kind of current source, though the value of that current is nothing but 0. So you can ignore this. So here we have only a resistor, because the current supplied by this current source is nothing but 0 ampere, so we can ignore this. So if you ignore this, the structure is something like this. We don't have any element over here. So it is simply a 2 by 3 ohm resistor which is connected in series combination with this practical current source. Now see here, what is our objective? Our objective is to find or to convert this entire network into equivalent voltage source. So what we need to do now, we need to apply source transformation technique one more time to convert this current source into equivalent voltage source. So if you apply source transformation method to convert this current source into voltage source, so how the structure is going to be look like. So here we have, this is going to be X, somewhere over here we have Y, and first what we need to do, we are going to convert this current source into equivalent voltage source. So it is going to be like a resistor followed by a voltage source. Now what will the value of this resistor? It is going to be equal to the internal resistance. So here the internal resistance is 6 by 5. So same 6 by 5 is going to be appear over here. Now we need to find the magnitude for this voltage source, which is nothing but V. So how it is going to be like this? So V is nothing but I into R. So I is 7, R is 6 by 5. So 6 sevens are 42. So this is going to be 42 by 5 volt. And what will be the polarity? Now see here, this current source is in upward direction, so arrow has to be plus. So this is going to be plus and this is going to be minus. I hope this is clear to everyone. I simply apply source transformation technique and convert this practical current source into equivalent practical voltage source. So here the internal resistance is 6 by 5, the same 6 by 5 is available over here, and the magnitude of current source is 7 ampere. So I apply Ohm's law to find the value of P, which is nothing but I into R. That is 7 into 6 by 5. That is 42 by 5 volt. And then we have this 2 by 3 ohm, which is connected in series with this. So here we need to connect that. That is nothing but 2 by 3 ohm. Now the answer is almost on the verge of completion. Now see here, we have a voltage source followed by two resistors which are connected in series configuration. That is 6 by 5. Along with that we have 2 by 3. Now what we need to do, if suppose we want to replace them by a final answer where we have x followed by y, so here we need to club them by a single practical voltage source. So this is going to be your R equivalent, and this is plus, this is minus, and the value of this voltage source is going to be 42 by 5 volt. Now what will be the value of this R equivalent? It is simply the effective series combination of this resistor followed by this resistor. So I can write here as 6 by 5 in series with 2 by 3, because these two resistors are now connected in series configuration. Remember one thing, whenever you are trying to find out the equivalent resistance, and while doing that we need to ignore the sources. While ignoring, normally we replaced these sources by their ideal condition. So in case of ideal current source, the internal resistance is supposed to be infinite. That's why whenever we are having a current source, and if you are interested to find out their equivalent resistance, we straight away replace them by open circuit. In the same way, we know that the internal resistance for ideal voltage source is nothing but 0. So whenever we want to find out the equivalent resistance in a circuit where we need to ignore voltage source, we are going to replace them by short circuit. This is very important. So ideal current source, we need to replace them by open circuit. In the same way, if you have a voltage source, we are going to replace them by a short circuit. So if you apply that logic, we can straight away ignore them. That means this 6 by 5 is connected in series with this 2 by 3. So if you apply that logic, we can find out this as 18 plus 10 divided by 15. So this is going to be equals to what? 28 by 15. So our equivalent is 28 by 15 ohm. I hope this is clear to everyone, and this is what our final answer is. So if you apply source transformation technique to this particular network and try to reduce to an equivalent practical voltage source, this is the final answer. So here we got the final answer as the effective voltage is 42 by 5 volt and the effective resistance is 28 by 15 ohm. That means if you have a structure between terminal X and Y represented by this particular entire combination, the same structure we can replace simply by this combination. कहने का मतलब है कि अगर आपके पास में एक्स और वाई टर्मिनल के बीच में अगर ये नेटवर्क है और अगर आपने सोर्स ट्रांसफॉर्मेशन टेक्निक अप्लाई किया, तो उसके बाद में आप ये स्ट्रक्चर ड्रॉ करना किया, या एक्स और वाई टर्मिनल के अक्रॉस में आपने अगर एक रेजिस्टर बताया जिसका वैल्यू 28 बाई 15 ओहम है और उसके सीरीज में अगर आपने एक वोल्टेज सोर्स लगाया ऑफ वैल्यू 42 by 5 volt with this kind of polarity, they are exactly going to be behave like a same. So we can reduce a very complicated structure into an equivalent voltage source, or you can say current source. So this is what the application of source transformation technique. In the next lecture, we will solve some more numerical on source transformation technique, and then we will switch to another network theorem, like what exactly the meaning of superposition theorem, followed by Norton's and Thevenin's theorem. Thank you.